Okay, this little video is about the solar water heater that I made. It starts off with a pump, and this little pump is a Rule, R-U-L-E. It's a pump that's designed to go in the bilge of a sailboat. Runs on 12 volt, and it only draws a couple amps, maybe 3.2 amps, I think, max. And you have to make a little bit of an adapter for it to get it to a garden hose, but that's all right. It's 12 volts, so it's safe underwater. It is waterproof, so it's intended to be underwater. It starts automatically as soon as there's electricity. It doesn't need a sump switch or anything, a float switch or anything to start it. As soon as there's electricity being fed to it, it starts. So we have a garden hose, black hose, of course black, draws the most heat. And then it comes over to a panel. The solar panel is a 100-watt solar panel. Less than $100, most places, Amazon, whatever. And I've added a toggle switch and a fuse. There's a 5-amp fuse on it. You don't actually have to have them on there, but I thought it would be a good idea. Now the water, when it comes from the hose on the pump itself, it goes over to the first panel. And these panels, they're both the same, but it feeds into the panel. There's a female connector on the end of the hose. The hose itself is a normal water hose, but the tubing is a DIG tubing. It's irrigation feed tubing. It doesn't have any holes in it or anything. It's not the stuff that goes underground or drip irrigation, but it's the stuff that's used to supply it. There's enough in there to do about 250 feet, and it's coiled into there. It's a 1/2-inch marine plywood, or exterior plywood, not marine plywood. And it does a pretty good job of collecting the heat. The polycarbonate is intended for greenhouses, and that helps to trap the heat in there and make it work a little bit more efficiently. Those two are connected together with a short piece of that garden hose. All female fittings on the ends, and so you have male fittings on the garden hose. You just pick those up at the hardware store. The thing works pretty good. It's a little bit of condensation in there right now, and that's a bit of a problem. I've sealed these with the intention of the bottoms being open and the tops being sealed and the sides being sealed. But once the moisture gets in there, it's going to stay in there. So we're going to have to take a look at how we get that moisture out. That'll improve the efficiency a little bit. But the water, when it comes back into the pool, is pretty warm. I mean, it's wash your hands warm. It's not burning hot, but at 800 gallons per minute, it wouldn't be very warm. It wouldn't be that warm, but it'd be pushing a lot of water through. So it all equals out, whether you run a pretty high flow with a lower temperature, or whether you run it slower and it has less heat in it, or more heat in it. It all equals out pretty well. So that's the system, and the total on the materials is probably around $450. You could do it cheaper. You could wrap saran wrap around it instead of buying sheets of polycarbonate greenhouse material. But the beauty of this system is that as long as the sun is shining, the pump will run. As soon as the sun stops shining, the pump stops. So it'll only pump water through those panels whenever there's a potential for a gain of heat. And it's self-regulating. You don't have to worry about turning it off, turning it on. The sun will do that for you, and it's continually gaining. And it's worked pretty well. The temperature in the water is already very nice. I don't have a temperature gauge at this point to measure it, but I know that you can expect to be about 20 degrees of increase in temperature from the pump over to the point where it goes back into the pool. You can expect that water to be about 20 degrees warmer.